Welcome back, guys, to another Exam P sample problem video solution. Today we'll be dealing with a problem that deals with a negative binomial distribution. So let's get right into it. So as always, I will show you and read the question to you in case you need to pause your video to write the question down. So we're doing problem number 197, and it says as follows. On any given day, a certain machine has either no malfunctions or exactly one malfunction. The probability of malfunction on any given day is 0.4. Machine malfunctions on different days are mutually independent. Calculate the probability that the machine has its third malfunction on the fifth day, given that the machine has not had 3 malfunctions in the first 3 days. Okay. So let's go ahead and pull up the OneNote app. Alrighty, and let's get started. So this is problem 197. So the first thing I'm going to do is I'm going to write our two random events. So I'm going to let X be the event that the event machine has its third malfunction. On the fifth day. And then I'm going to let Y be the event machine hasn't had three malfunctions in the first 3 days. And our goal is to find probability X given Y. Okay. So now we set the problem up. This is our goal. So the first thing I want to do is kind of just expand this a little bit. So we know the probability of X given Y is probably X intersect Y divided by the probability of Y. Well, we know that the intersection of X and Y in this case is just X, because the event having its third malfunction on the fifth day is talking about time past the first 3 days. As you see here, Y is the event the machine hasn't had 3 malfunctions in the first 3 days, and X is dealing with the third malfunction on the fifth day. So that's why we can go ahead and say that this intersection is just the probability of X, and then divided by the probability of Y. So our goal is we need to find these two probabilities of these two events. So now let's go ahead and get the easiest probability out of the way. So we know the probability of Y is equal to 1 minus the probability of Y complement. Well, we know that the complement of Y's event in this case is that all 3 malfunctions are in the first 3 days, right? That's just negating the negation or the complement of this event Y. So the only way that you have 3 malfunctions in the first 3 days is if you have 1 in each day. And since they're independent, we can say that the probability of Y complement is just, in this case, 0.4 cubed. We're told the probability of a malfunction on any given day is 0.4. I didn't write that down, but that's in the problem. So this actually ends up being 0.936. So we've got one piece of the puzzle. We've got probability of Y. So probably the most difficult part of this entire problem is realizing that X is a negative binomial distribution. We know that negative binomial is the number of Bernoulli trials or something with having an R success is like the general definition, where R is the amount of successes. Or in this case, we want the third malfunction on the fifth day. So in general, for a negative binomial, so let me go and write this. So we know X is negative binomial with R equal 3, and then our probability is still 0.4. And in general, the PMF of a negative binomial is probability x equals little x equals x minus 1, r minus 1. So x minus 1 choose r minus 1 times the probability raised to the r power times 1 minus p times the x minus r power. So applying that to this problem, the probability that x equals 3 is, so we know that we're talking about the 5th day, so x is 5. So actually this should be 5, sorry. So we have 5 minus 1, choose 3 minus 1, times p, which is 0.4, raised to the r power, which is 3, r is 3, times 0.6, because we know 1 minus 0.4 is 0.6, raised to the 5 minus 3 power, which is 2. So just take a second there and let's just look over this again. So this right here is what we want. We want the on the 5th day, right? So this 5 represents the day of the week in this problem, and then 3 is the amount of malfunctions we have in that 5-day period. We want to have the third malfunction on the 5th day. That's why this is a negative binomial distribution. Okay, so this ends up being 4 choose 2 times 0.4 cubed is 0.064. 0.6 squared is 0.36. So this ends up being 4 factorial over 2 factorial times 2 factorial times 0.064 times 0.36. And plug that into your calculator and you get 0.13824. So as we said, we know this is the probability of x. Okay, so now we're finished. We just had to plug it into this goal equation. So therefore, probability x given y equals probability of x is 0.13824 divided by the probability of y, which is 0.936, and this equals 0.1477, and that is your final answer. Yeah, so this problem actually gave me a little trouble. It's a very tedious problem, and if you don't recognize the negative binomial distribution, you can't solve it. So just make sure you're able to pinpoint the distribution, because that's something I'm really trying to study and work on, is being able to pinpoint distributions without the problem telling us, because the SOA is very sneaky. They're not just going to straight up tell you most of the time that it's a negative binomial. You just kind of have to know that by the definitions that we know of the distributions. And I found that the discrete distributions tend to be a lot more sneaky, in the sense that they don't usually tell you whether it's Poisson or negative binomial, geometric, hypergeometric, and whatnot. So just be very, very attentive to the way that the questions are phrased. All right, guys. Well, thank you for tuning in for another video solution. I hope that this helps you. There's not, from all my searching on the internet, there's not a solution to this problem on the internet. So hopefully this video solution might be better than the written solution SOA has. So thank you for watching and have a great rest of your day.